Coding has been the bread and butter for developers since the dawn of computing. We're used to creating applications by breaking down requirements into composable problems that can then be coded against. So, for example, if we have to write an application that figures out a stock analytic, maybe the price divided by the ratio, we can usually write code to get the values from a data source, do the calculation, and then return the result. Or, if we're writing a game, we can usually figure out the rules. For example, if the ball hits the brick, then the brick should vanish and the ball should rebound. But if the ball falls off the bottom of the screen, then maybe the player loses a life. We can represent that with this diagram. Rules and data go in, answers come out. Rules are expressed in a programming language, and data can come from a variety of sources, from local variables all the way up to databases. Machine learning rearranges this diagram where we put answers and data in, and now we get rules out. So instead of us as developers figuring out the rules, when should the brick be removed, when should the player's life end, or what's the desired analytic for any other concept, what we'll do is we can get a bunch of examples for what we want to see and then have the computer figure out the rules. Now this is particularly valuable for problems that you can't solve by figuring the rules out for yourself. So consider this example, activity recognition. If I'm building a device that detects if somebody is, say, walking, and I have data about their speed, I might write code like this. And if they're running, well, that's a faster speed, so I could adapt my code to this. And if they're biking, well, that's not too bad either. I can adapt my code like this. But then I have to do golf recognition too. Now my concept becomes broken. But not only that, doing it by speed alone, of course, is quite naive. We walk and run at different speeds uphill and downhill, and other people walk and run at different speeds to us. So let's go back to this diagram. Ultimately, machine learning is very, very similar, but we're just flipping the axes. So instead of me trying to express the problem as rules, when often that isn't even possible, I'll have to compromise. The new paradigm is that I get lots and lots of examples, and then I have labels on those examples, and I use the data to say, this is what walking looks like, this is what running looks like, this is what biking looks like, and yes, even this is what golfing looks like. So then it becomes answers and data in, with rules being inferred by the machine. A machine learning algorithm then figures out the specific patterns in each set of data that determines the distinctiveness of each. And that's what's so powerful and exciting about this programming paradigm. It's more than just a new way of doing the same old thing. It opens up new possibilities that were infeasible to do before. So in the next few minutes, I'm going to show you the basics of creating a neural network, which is the workhorse of doing this type of pattern recognition. A neural network is just a slightly more advanced implementation of machine learning, and we call that deep learning. But fortunately, it's actually very easy to code, so we're just going to jump straight into deep learning. We'll start with a simple one, and then we'll move on to one that does computer vision in about 10 lines of code. But let's start with a very simple hello world example, so you can see just how everything hangs together.